Hey people, and welcome to this video. In this video, we'll be working on the Mathematics Paper 1, and this is the preparatory exam for 2024 from the Gauteng province. This paper is worth 150 marks and the time allocated is 3 hours. Make sure to round off to 2 decimal places unless stated otherwise. The diagrams are not necessarily drawn to scale, and you also have a formula sheet at the end of the question paper. Okay, with that being said, let's get into this video. Question 1 says 1.1, given 2k is equal to x minus 5 multiplied by x minus k, we need to determine k if x is equal to 2. So all we're going to do is, in place of x, we're going to substitute 2. So our equation will look like this. 2k is equal to, and then we're going to replace that with 2 minus 5. And then again, there's an x, we replace it with 2 and minus k. And let's go ahead and solve for k. So 2k equals, and 2 minus 5 is negative 3. So we have minus 3 and multiply by 2 minus k, which we can distribute. So you can either choose to distribute it like this by foiling it out, or you could also just divide both hand sides by this 2. Either ways, it will still work out fine. So let's go ahead and just distribute. So this is going to be, we have 2k is equal to, and we have negative 6 and plus 3k. Okay, and now we can transpose the 2k just so that it can come over with this k over here, and then transpose the negative 6. So that becomes a positive 6, and that is 3k minus 2k. And therefore, this means that k is equal to 6, and that is our answer. Moving on to the next question. The next question, question 1.1.2, says we need to solve for x, determine the value of x if k is equal to 2. So it's still the same equation, but this time we are substituting a value for k instead of x. Okay, so this looks like this, and in place of x, we're going to leave these as x, and in place of k, we're going to substitute 2. So that's x minus 2, and then 2 times 2 over there. Okay, let's go ahead and distribute. So we have 4 on this side is equal to, and if you FOIL this out, this will be x squared, and then negative 2x, and plus 10. And then this is, we can just say, transpose that 4. So we have x squared, and then simplify. So this is x squared, and then minus 7x, and plus 6 is equal to 0. Okay, and now we can just factorize this. So open up 2 brackets, set it equal to 0, and then x times x gives us x squared, and then factors of 6 that give us 7. Okay, you can have 3 and 2, but you see that that won't help to give us a 7. Now, you see that the 6 is positive. So we're going to try factors 1 and 6. Now we can see that the 6 is positive. So you can either make this positive 6 times positive 1 to get positive 6, but the middle term is negative. So the other way that we could get that to stay positive is by saying negative 6 and negative 1. So negative 6 times negative 1 gives us positive 6, but negative 6 minus 1 is negative 7. Okay, so therefore, it means that x is either equal to 6 or x is equal to 1. And those are our answers. Question 1.2, we are told to solve for x in 1.2.1. And we have to correct to 2 decimal places. So this means that this is going to be a quadratic equation with irrational solutions. Okay, so you can see that it's not in its standard form yet. One hand side should be equal to 0. So now it's going to be 2x squared minus 8x plus 3 is equal to 0 when we transpose that, positive 8x. And now that it's in standard form, we can use the quadratic equation, which looks like this. And now we're going to substitute our values. So x is equal to negative, and the value of b, as we can see, is negative 8. So that's negative 8 plus minus the square root of, and we have b squared, which is again negative 8. So that's all squared, minus 4 times a, which is 2, and then c, which is 3, and all of that is square rooted, all over 2a, which is 2. Okay, so we just have to get both solutions. So let's try the positive and negative solution. And going with the positive, we get that x is equal to 3.58 rounded off to 2 decimal places, and we change that to a negative, then x is equal to 0. And you see that 1, the second decimal, because of the 8, it's going to round up to a 2. So that is 0.42. And those are our solutions. Question 1.2.2 says we need to solve for x in this equation with a surd. Okay, so with equations with surds, you have to ensure that the surd is isolated so we can square both sides and get rid of that surd. So we're going to leave this as it is, but we can't just distribute this out. That's fine. And I would have actually wanted to leave it on its own, but I see that when we take negative 10 over, it's not like both terms here are going to be divisible by 2. If they were, we could have just said divided by 2 and then divided by 2 when we take that over after squaring both hand sides. So it's fine. You can distribute here. This is going to be 2x and then plus 20 is equal to, and we have x, and this is negative 12. But when the negative 10 gets transposed, it's going to be positive 10. So that is 10 minus 12, which is negative 2. Okay, so this is what we have. And now at this point, we can square both hand sides. So if we square both hand sides, here, that radical breaks open, and we have 2x plus 20 is equal to, and we can just distribute here. So the first term squared is x squared. The last term squared is positive 4. And then first term, second term is negative 2x. And then you multiply that by 2, giving you negative 4x. And this is going to be x squared minus 4x, and then we'll say minus 2x, of course, which will give us negative 6x. And then positive 4 minus 20 is negative 16, okay, is equal to 0. And now we can factorize. So this is equal to 0. And what times what gives us x squared? That's x times x. And now we need factors of negative 16 that can give us a 6. Okay, so 16, you could try 2 and 8. Okay, that would probably work. Negative 16, try 2 and 8. So which should be negative? Because this is negative. 1 should be negative, but we need to ensure that it gives us a negative 6 in the middle. So you have to give the negative to the bigger factor. Okay, so give the negative to the 8, and then this stays positive. So this is positive 2 and negative 8. So therefore, x is equal to negative 2, or x is equal to positive 8. Now, here's the thing. Yes, we have found the values of x, but you see that originally in this equation, the highest exponent on x was a 1. Then we did something, and the highest exponent on x is now a 2. Okay, because of that, we could have tampered with the solutions. So we need to ensure that these solutions are valid. So take your equation with surds. You can take it from this point. It's fine. Just don't square both hand sides. So take it when it's still a surd. Okay, so we'll remove these. And we're going to substitute x into this equation. And we need to ensure that the left-hand side is equal to the right-hand side. So in place of x, we'll simply say, let's try negative 2. So negative 2 to see if this is our solution. And what happens here? So if we multiply these two, they give us negative 4. 20 minus 4 is 16. The square root of 16 is 4. Okay, so that's what we have there. But negative 2 minus 2 is negative 4. These are not the same number, okay? So the left is not equal to the right, meaning x is not equal to negative 2. Let's go ahead and try 8 to ensure that that is our solution or not. Okay, so when we try 8, let's see what we will get here. So 2 times 8 is 16. 16 plus 20 is 36. The square root of 36 is 6. 8 minus 2 is 6. Perfect. The left-hand side is equal to the right-hand side, so it means that x is equal to 8. You're going to get a mark for cancelling one and accepting the other because they're not always both valid. Okay, so that is it for this question. Moving on to the next question. Question 1.2.3 says we need to solve for x, or find the values of x, for which 3 to the power of x multiplied by x minus 5 will give us a value less than 0. So, what should x be so that when you take 3 to the power of x and multiply it by x minus 5, it gives us values that are less than 0? Okay, which x values would work for this? Now, this is not the usual type of exponential equation or inequality that we usually get. So let's think about this logically. We have 3 to the power of x multiplied by this, and it needs to give us a value less than 0. Here's one way that this could happen, okay? There are just two things being multiplied, and they must give you a value that is negative, a value less than 0. If this was positive and this was negative, if you multiply them, you get a value that is negative. Okay, so we'll look at that. And if this was negative, multiplied by this being positive, would also get a value less than 0, negative. But now let's just think about it logically. It needs to work out for both, okay? They need to both be either positive and negative, or negative and positive, and it needs to work out. So looking at it like this, 3 to the power of x, right? If it needs to be positive, we're saying that it needs to be greater than 0. So what are the values of x for which this will be greater than 0? You can think about this like this. Since this is actually an exponential function, you can think about it like an exponential function. And the base is positive. So this is an increasing function. It has a positive coefficient of 1 that is invisible there. So it's going up like that. And you notice that it doesn't have any q value or that horizontal asymptote. And so that would mean that that q value is actually at y is equal to 0. Remember, if you don't see a visible q value, it means that q is equal to 0. So this is what that graph would look like. And what we're solving for here is we're finding the values of x for which this graph's y values, okay, it's 3 to the power of x. The function as a result of substituting x, those will give you y values. We're trying to find the values of x for which this will be greater than 0. So looking at your y-axis, because we're looking at y values, you see that all the values greater than 0 are here. So the graph is going to have y values greater than 0 wherever it has positive y values. It has a positive y value here and here and here, and it keeps having positive y values all through. So this means it's going to work for every single x value. It will always have positive y values. So the solution to that is that x is basically just an element of all real numbers. Okay, so we're saying that this will work as long as x is an element of all real numbers. Okay, let's see how this now pairs with this. Remember that this is positive and this one must be negative. So we're saying that x minus 5 must be less than 0. And this is a linear inequality. So this would simply mean that x must simply be less than positive 5 when we transpose that negative 5. So if this one is saying I will work for anything, okay, as long as you're a real number, I will work. And this one, you just have to make sure that this is always a value that is less than 5. Then it means that for them to both be true, okay, for those two situations to be true, then we would have to say x is really just less than 5. This would have to be our answer in this case. Here is why. If we say x is an element of all real numbers, well, that doesn't agree with that. They both have to agree. That's the one thing. Okay, so x can't just be an element of all real numbers because this one is specifically saying x needs to be less than 5. So we need to just basically say that x is less than 5, and this will cover every value less than 5, and this will be all real values that are less than 5, and that would be our answer because they must both be true. Okay, now that's the first case. Now looking at the second case, can this ever work out? First of all, 3 to the power of x, can that be a value that is negative? Can that give us a negative value, a value less than 0? This is not possible because if you say 3 raised to the power of any number, it's always going to give you a positive value. It's not even going to give you 0. okay? Because even 3 to the power of 0 is 1. Now, if you say 3 to the power of, try a negative number, like negative 1, that's going to be 1 over 3. And 3 to the power of negative 2, that's going to be 1 over 9. It's always going to be positive. So this can't happen. And so we're not even going to consider the second case. And it would simply mean that our answer is x needs to be less than 5. Okay, it would be very important to show them these two parts, right? And also telling them that was the answer to that. That's the criteria for this to be true. And then this part, and then your final answer. Okay, so that is our answer. Moving on to the next question. Question 1.3 says, solve the following equations simultaneously. Okay, so we have an exponential going on here, and we've got this, where the highest power on y is 2. So you're going to always have to look for the equation that is either linear or can at least become linear. Now, looking at these two equations, this one, we can actually take that further because they're using interesting bases here. They're using 3, they use 9, they use 27. What do they all have in common? All these numbers can be expressed as a base of 3. So that's what we're going to do. So with this one, despite the fact that it has a square root, we can still express it like this. So it's going to be 3 to the power of, and it's the inside exponent over the outside exponent. This is a square root, so that outside exponent is a 2. So we have x over 2. Multiply by 9 to the power of y, which we can express as 3 squared. That's the 9 part. But then it's to the power of y, so this is to the power of y, which just multiplies and becomes a 2y. And then is equal to 27, and we can express that as 3 to the power of 3. Okay, so this is simply just going to be these two multiply because the bases are the same and we are multiplying. So 3 to the power of, and we're going to add the exponents. I'm just going to call this a 1 over 2x because that's how we can express it since there's a 1 in front of the x, and plus 2y is equal to 3 to the power of 3. And we can take this further. So finally, because the bases are the same and this is an exponential equation, we can equate the exponents. So this is simply 1 over 2x plus 2y is equal to that exponent of 3. Okay, now since we're already just taking this equation further, we have to make something the subject. I'm just going to go ahead and make x the subject. It's fine. We have a half x is equal to 3. And transpose the 2y, so minus 2y, and now we can get rid of that half. So you can divide both hand sides by half, or you could just multiply both sides by 2 over 1, which is 2. So multiply by 2 here, and what we will get is x is finally equal to 3 times 2 is 6, and negative 2y times 2 is negative 4y. And there we go, we have something as the subject. We can go ahead and call this equation 1. You could have started by calling that equation 1 and then taking it further and calling it equation 3 after this one is called equation 2. But it's also fine like this. So now we can substitute equation number 1 into 2. So wherever you see x, replace it with 6 minus 4y. Okay, so this is going to be, we have x, so we're going to say 6 minus 4y and then plus 4y squared is equal to 6. Okay, let's simplify. Okay, so we can see this is a quadratic equation, but you have positive 6 on both hand sides. If you transpose 1, it's going to be 6 minus 6, so you can already cancel it out on both sides now. And so we just have 4y squared minus 4y is equal to 0. Then we can take 4y out as a common factor because this is a binomial, and we have a common factor of 4y. And this is going to be y minus 1 is equal to 0. And then 4y is equal to 0, or y minus 1 equals 0. If you divide both hand sides by 4 here, y is therefore equal to 0. And here transpose the negative 1, y is equal to 1. Okay, so those are our two solutions for y. And now that we found y, we can find x. This is the only equation where x was nicely the subject. So we can substitute those values of y into this equation. So we're simply saying that x is equal to 6 minus 4, and in place of y is 0, therefore x is equal to 6 minus 0, which is just 6, or x is equal to 6 minus 4 times 1, and that's 6 minus 4, and therefore x is equal to 2. So there we go. X is either equal to 6 and at the same time y is equal to 0. That is the first point of intersection. Or x is equal to 2 and y is equal to 1. Second point of intersection. And those are our answers. Question 1.4 says the solutions of a quadratic equation are given by x is equal to, and we have negative 2 plus minus the square root of, that plus 5 over 7. The quadratic equation. Now, I'm going to put down the quadratic equation over here so we can just compare it, okay? The one that you have in your formula sheet. Okay, so this is what it looks like. And we need to state the value or values of p for which this equation will, first of all, have two equal solutions. Okay, so this is referring to the discriminant. And the discriminant is that part, b squared minus 4ac. So how will it have two equal solutions? Okay, so the same x value. This looks like this. X minus 1 times x minus 1. Okay, so that will be equal roots. Well, this will happen if the discriminant, b squared minus 4ac, which we can clearly see now is this 2p plus 5 part. If the discriminant is equal to 0, then you're going to have the exact same equation. And that makes perfect sense because if this is equal to 0, you're just saying square root of 0, which is 0. So the only thing left would be that negative b over 2a. In this case, negative 2 over 7. That will be the only root. So this means that 2p is equal to negative 5. Divide both hand sides by 2 and p is equal to negative 5 over 2. And that is what p needs to be to have equal solutions. And 1.4.2, the last question for question 1. What must p be for us to get no real solutions? No real solutions. The only way we can get no real solutions with that discriminant, controlling that, is if the discriminant b squared minus 4ac, which we now know is 2p plus 5, if this is simply less than 0. Why? Because it's going to be non-real as long as that part is a negative number. What happens when you square root a negative number? You get a non-real solution. On the calculator that you are allowed to use for exams, it's going to say math error. Okay, so that's what we're going to do here. And then, you see, we don't really have to stress about solving this equation. We just solved it. We found out that p is equal to negative 5 over 2. And we didn't divide by any negative number. We only divided both hand sides by 2. So this is simply p just needs to be less than negative 5 over 2. You can go through the whole thing of dividing it, but it's a linear inequality, so it will not change. Okay, it does not work like a quadratic inequality. And that is our answer. And that is it for question 1. Question 2, 2.1 says, given the quadratic sequence 0, 5, 14, and then this goes on to 779 and 860, 2.1.1 wants us to write down the value of the fourth term, T4 of this sequence. Okay, so let's rewrite our pattern down first. Okay, and they want us to find the fourth term. So T4 is over here. This is a quadratic number pattern, so we can find the first differences first. So that is 14 minus 5, which gives us 9, and then 5 minus 0, which gives us 5. So that's the first difference. And now let's find the second constant difference. So that's 9 minus 5, and that gives us 4. Now, how we can find the fourth term is because we know that the second constant difference is constant, so it will continue to be positive 4. So the third term in the first differences would be 9 plus 4, which gives us 13. And then to get the fourth term, we would say 14 plus 13, which gives us 27. Therefore, term 4 is equal to 27. And that is our answer. Question 2.1.2 says, determine an expression for the nth term of this sequence. So we already have the first terms of the quadratic pattern, first difference, and the second constant difference. And that's all we need to find the Tn formula for this pattern. So we're going to take the first terms in each of these patterns and we will equate it to the following. So the first term in the second constant difference will be equated to 2a. Then this will be equated to 3a plus b. And this will take a plus b plus c is equal to 0. And now we're going to find the value of a, b, and c. So 2a is equal to 4. So therefore, a would be equal to 2 when we divide both hand sides by 2. And then 3a plus b, but we already know what a is. It's 2 plus b is equal to 5. And so we'll say b is finally equal to 5. And 3 times 2 is 6. If you transpose that, that is a minus 6. So 5 minus 6 is negative 1. And to find c, we're going to say a plus b plus c equals 0. But we already know what a is and what b is. And then plus c is equal to 0. And so c is equal to 2 minus 1 is 1. And if you transpose 1, it gives you negative 1. So the nth term of a quadratic sequence is in the form of Tn is equal to an squared plus bn plus c. So therefore, our pattern's formula is 2n squared minus n minus 1. And that is our answer. Question 2.1.3 says, calculate the number of terms in the sequence. Okay, so looking at this sequence, going from 0, 5, 14, and then it has 7, 7, 9, and then 8, 60. We can see that this is the last term. So if we find out what term number this is, then we'll find out exactly how many terms there are. So the question is, what term number is this? So meaning that this is Tn, we're trying to find out what exactly n is, because when we find out that, it will say term, for example, term 20 is equal to 860. So in place of Tn in our term formula, our general term formula, we're going to substitute 860. Okay, so 860 is equal to, and now we're going to transpose 860. So we have 0 is equal to 2n squared minus n. What is negative 1 minus 860? And that is negative 861. Okay, so we just have to factorize this. At this point, you can go ahead and just use the quadratic formula, but you can still include factors despite the fact that you've used the quadratic formula. Okay, so on your calculator, we're just going to substitute, and I'm not going to put the quadratic formula down because it's not really that necessary. So we're saying the quadratic formula looks like this. And we'll say negative b, so that is negative 1. And plus minus, we'll start with the plus, square root of negative 1, all squared, minus 4 times a, which is 2, and then times c, which is negative 861, all over 2a. So that is 2 times 2, okay? Because we can see the value of a, b, and c. And you see that the first factor we get is 21. Now, here is what that means. It is 21 because that is our answer. That is the solution for n, meaning we factorized, okay? We found the factors and said it's equal to 0. And then we're able to solve for n and say n is equal to 21. So if n is equal to 21, what is the factor you would have had first before solving for n? That would be n minus 21. Because if you said n minus 21 is equal to 0 and you transpose the negative 21, you'd get positive 21. Okay, and now here's how to see the second one. So in this case, we'll change that positive to a negative. And now that says negative 20.5. Now make sure it's as a fraction so you can better understand it. So it means that here it said n was equal to negative 41 over 2. So what this means is you can start by transposing this negative 41 over 2. So that's n plus 41 over 2. But the reason it got to this point is because this 2 was actually the coefficient of the n. So you actually had 2n plus 41. And then you said 2n plus 41 is equal to 0. And then 2n is equal to negative 41. And then you divided both hand sides by 2. Okay, so here's another way that you could factorize if the factors, did not look as simple as the ones in the first question. Okay, now let's make our decision. They want us to find the number of terms in the sequence. Remember that terms are always going to be non-fractional numbers. So we cannot take this, and we can't also take it because it's negative. Okay, terms are not negative, they're positive. So it means that there are 21 terms in this pattern. And that is our answer. Question 2.2 says, determine the sum of the whole numbers between 100 and 1000 which are divisible by 11. Okay, so if the numbers are divisible by 11, let's just first of all make a smaller example so you can understand this. If I said find the sum of the whole numbers between 1 and 10 that are divisible by 2, then these are numbers that can be divided by 2, meaning they're numbers that are counting in twos. Okay, so these will be numbers like 2, 4, 6, and 8. Okay, and those will be the numbers and would have to sum them up. So in this case, because the numbers are divisible by 11, it means that these are numbers that are counting in 11. So we already know that this is going to be a linear pattern because we are counting in a fixed number, okay, adding 11 every time. And we will also know that it's a linear pattern with the difference being 11. Okay, and now we know that the numbers are between 100 and 1000. Now we know that 100 is not divisible by 11. Okay, even if it was, we couldn't take it because it is the numbers between these numbers, not including them. So let's focus on 100. What is the closest number to 100 that we know is divisible by 11? You can think about 9 times 11. That gives you 99. So we'll have 99. It's not included in the pattern, but if we have 99, then the next number divisible by 11 would be 99 plus 11, which is 110. Okay, so we just found the first number in this pattern, 110. And then we need to know where it ends because we already know it's arithmetic. First of all, it's linear. We know the difference. Now, in order to find that sum, remember there are actually two formulas, and we'll speak about that in a bit. So let's look at the 1000 now. What is the closest number to 1000 that is divisible by 11? For this one, because we are by 1000, we can look at 90 times 11, which is 990. If you add 11 to this, then you're going to end up with 1001, okay, which is right here, you see, so that is above 1000. So we can see that the next number divisible by 11 that is less than 1000 would be 990. And there we go. We've just found the first and the last term in the pattern we're referring to. So that is the 110 and the 990. Okay, so we have what we need. Now we need to determine the sum of the whole numbers, right? So to find the sum, we can either use this formula, okay, with the first and the last term, or we could use this formula, okay? Now, any of it is really fine here. But from this, you'll see that the next thing we need to find would be the value of n. How many terms do we actually have in this series? So I'll go ahead and use this one, but we still need to find n. Okay, now in a situation like this, there's actually two ways that you can use to find n. You can use the Tn formula because we have d, we have a, this is the first term in the pattern, and that is enough to find n. So we could simply say Tn is equal to a plus n minus 1 because this is a linear pattern, it's counting in 11s. And we have Tn is equal to, say, 110 plus n minus 1 times the difference. And then we would substitute the last term because that will tell us how many terms we have since it will tell us the term that you ended at. Okay, so that is 990 is equal to 110 plus n minus 1 times 11. And then we can just find it. Okay, and that would be, if you transpose the 110, that's going to be 880 is equal to 11 times n minus 1. And then if we divided both hand sides by 11, then it means that n minus 1 is equal to 880 divided by 11 is 80. And then if we transpose the negative 1, n is equal to 80 plus 1, which is 81, right? And there we go, we'll be able to find that. But there's actually an easier way to have found this instead of using the Tn formula. Here's how we could have found this. We know that the first term starts at 110 and the last term ends at 990. We could have just looked at it like this. If we were actually counting in 11 starting from 11, then 11 would be term 1, and then 22 would be term 2, and 33 will be term 3, and so on. But since we started at 110, we could find out what term number this would be if this was actually the pattern. And it would be easy to find that because term 11 is 11, because if you said 11 divided by 11, you get 1. So that's the first term, meaning you took 11 and you multiplied it by 1. Okay? And then 22 is the next term because you would have said 11 multiplied by 2. And 33 would be the next term because that would be 11 multiplied by 3. Since each term is just being added by 11. So this one, we could have just found out what 110 divided by 11 is, which we know is 10. And then 999 divided by 11, that is 90. And so like this, you could have simply said the last term, it's kind of like with that sum. We're starting at n equals 10 and we're ending at 90. So we would have just said 90 minus 10 plus 1. And so 90 minus 10 is 80, plus 1 is 81. So that's another way that you could have found it as well. Okay, but all in all, we have everything we need. We have the value of n, a, and l, and we can find the sum of these terms. So the sum of how many terms, that's 81 terms, is equal to, and we'll say in 81 over 2, following the formula, and then a, which is 110, that's where our pattern starts, and plus l, which is 990. And we'll find out what the sum of these 81 terms are. And our answer is 44,550. And that is our answer. And that is it for question 2. Question 3, 3.1 says, given the geometric sequence, and we have 8, and then x minus 2 all squared, and then 4, and then x minus 2 all cubed, and you can see what's going on here. And they tell us that x is not equal to 2. And question 3.1.1 wants us to determine the value or values of x where the sequence converges. Now, I don't want to waste too much time on this question, but let's look at a quick explanation on how sequences converge. I want you to think about this like a piece of bread. And we can record what happens to this piece of bread when we cut it in half every time. So right now we have a whole piece of bread, and we can say that is one whole that we have. And if we cut it in half, then we have half a piece of bread. Okay, so we have a half. And if we cut that in half, then we have a quarter of that slice of bread. And if we cut that again in half, and now we have an eighth. And basically, you see where this is going. If we keep cutting this in half, and then again a half, and then a half of that, and a half of that, eventually you see how this piece of bread is getting so small that it looks like it's going to eventually become nothing. But that's impossible. It can't become nothing because we're not magicians. We didn't make the bread disappear. It's just going to become so small that you may not be able to see it. And that's what happens with series or sequences that converge. The next term gets proportionally smaller than the previous term, and it gets so small and gets closer and closer to a specific number. In this case, it's getting closer and closer to 0. The whole point of this question is to determine the values of x for which this sequence converges. The criteria for a sequence to converge is that the common constant ratio should be greater than -1, but less than 1. If this is met, the series will converge. Okay, now let's get rid of this info so we can find out exactly what that common ratio is in our sequence. Okay, so let's go ahead and find out what the value of r is going to be. How do we find the common ratio in a geometric sequence? Well, you can say the next term divided by the previous term. So r is simply equal to 4 multiplied by x minus 2 all cubed divided by 8 multiplied by x minus 2 all squared. And when we simplify this, if we divide here, really what happens is in the numerator, 4 divided by 4 is 1, and 8 divided by 4 is 2. So that's what remains in the denominator. And then here we have the exact same base, but here we have 3 and here we have 2. So it means that they are common in both. So we are going to cancel x minus 2 raised to the power of 2. That divides by itself and becomes 1. And then it also divides here, but there's 3 of it here. So we know that only 1 would be left here. So our answer here is we still have that x minus 2, okay, raised to the power of 1, but we can just write it like that, all over the denominator of 2 that was left. And this is our ratio. So for it to converge, we need to ensure that this ratio x minus 2 all over 2 is greater than -1 but less than 1. And now we can go ahead and solve for x for which this is going to be possible, for which this inequality will be true. So to find the value of x, we're just trying to get closer to that x. So what is stopping us right now would be the 2. So we're going to multiply all the sides by 2. So multiply by 2 over there and over here, and of course on the inside as well, because these are really just two inequalities that have been written together. Okay, and that gives us -2. Okay, and over here we have the x minus 2 now, since this will cancel in the denominator, and then it's less than 2. And you see that all that is left is to transpose the -2. So when that goes over on this side, it becomes a +2. So -2 plus 2 is equal to 0. And then we have x here, the -2 is gone, and it goes over here as well. And that becomes a +2, which is going to be 4. So these are the values of x for which it will converge. X simply needs to be greater than 0, but less than 4. And that is our answer. Question 3.1.2 says, determine the sum to infinity of the series if x is equal to 2.5. Okay, we know that the sum to infinity formula looks like this. It is in your formula sheet, a over 1 minus r. So we just need to find the value of a and the value of r if we know that x is equal to 2.5. So the value of a is the first term, which was this, and the value of r is this. So let's go ahead and substitute x in place of a and r. So if we substitute 2.5 here, then this expression is equal to 2.5 minus 2 is 0.5. 0.5 squared is 1 over 4. And 1 over 4 times 8 is 8 over 4, which is 2. And here, if we substitute 2.5, 2.5 minus 2 is 0.5. And 0.5 divided by 2 is 1 over 4, which is 0.25. Okay, so the value of r is 1 over 4. And now we can just put this into the sum to infinity formula. So sum to infinity is equal to 2 over 1 minus a quarter. This will give us 3 over 4, and this is 2. So you're just saying 2 divided by 3 over 4, where you can use tip and times, or you could just use the calculator. So this is going to become times 4 over 3, and 2 times 4 is 8. So our answer is 8 over 3. And that is the sum to infinity. Question 3.2 says, we are given the sum starting at k equals 3 and then at 12 of the series with this formula. And we can see that this is a geometric series because the unknown variable is in the exponent. Okay, so 3.2.1 says, how many terms are there in this series? Easy way to calculate the number of terms is, you are saying we're starting at k equals 3 and ending at k equals 12. So just simply say 12, the top number minus the bottom number, and then plus 1. And that is going to be 10. Okay, so there are actually 10 terms in this series, starting at k equals 3 and then 4, 5, 6 all the way to 12. And that is our answer. Question 3.2.2 says, calculate the sum of the series. So the sum of this series, to find the sum, they didn't necessarily say it's a converging series, and we can see the ratio. Now, here's how to spot these things. You see that we have 3 times negative 2 raised to the power of k minus 2. Because you have a k right there, okay, and that k is not negative, it means that whatever the base is, whatever is carrying that exponent, that is your ratio. So in this case, r is actually equal to negative 2. Had the k been negative, then it would be a little bit of a different story. But remember, if you're not sure, what you can do is expand this series starting at k equals 3. You substitute 3 in place of k, and then that will give you the first term. Then substitute 4 in place of k, and that will give you the second term. And you'll simply just say the second term divided by the first term to find out what r is. Okay, but r is equal to negative 2. And from that, we know that to find a, the first term, you're simply going to substitute whatever k value we start with, and that will be your first term. So let's substitute 3 in place there. If we substitute 3, saying that we have 3 multiplied by negative 2 to the power of 3 minus 2. 3 minus 2 is 1, okay? And anything to the power of 1 stays the same. So this is 2 times negative 2. So a is equal to negative 6. And we know now that r is negative 2. So we have everything we need to find the sum of the series. We also know the value of n, which we found in the previous question, as 10. So the sum of the series, because r is a value that is less than 1, we're going to go ahead and use this formula. So we'll say Sn is equal to a multiplied by 1 minus r to the power of n over 1 minus r. So the sum of 10 terms is equal to negative 6 multiplied by 1 minus negative 2 raised to the power of 10, and then 1 minus r, which is 1 minus negative 2. And let's go ahead and find out what the sum of 10 terms give us. And the sum of 10 terms is 2046. And that is our answer. And that is it for this question, and that is it for question 3. Question 4 says, the graph of f of x, which is equal to ax squared, where x is less than or equal to 0, is sketched below. The point P, which is negative 6 and negative 8, lies on the graph of f. And the first question asks us to calculate the value of a. Okay, so we have a graph, a parabola, a restricted parabola, and we have 1 point on this parabola. So we can go ahead and substitute that point to find the value of a. So our graph f of x is equal to ax squared, and we can go ahead and substitute negative 6 and negative 8. So in place of y, we're saying negative 8 is equal to, and a multiplied by, in place of x, we're saying negative 6 all squared. So this is negative 8 equals 36a. And if you divide both hand sides by 36, therefore, a is finally equal to negative. You can see that they are both divisible by 4. So our final answer is negative 2 over 9. And that is the value of a. Question 4.2 says, determine the equation of the inverse in the form of y is equal to. So our equation now says f of x, or y, let's just write it as y, is equal to negative 2 over 9 x squared, because we know what the value of a is. And we have to find its inverse. So the inverse will be found by swapping x and y. So it's now y equals negative 2 over 9 y squared, and then making y the subject. So to make y the subject, we need to get rid of this negative 2 over 9. So we can do that by dividing both hand sides by negative 2 over 9, or multiplying both hand sides by negative 9 over 2. So the reciprocal of this, swapping the numerator and the denominator. And what you do on one side, you have to do on the other side, because this is an equation. So therefore it means that y squared, writing it here, is equal to negative 9 over 2x. And then we'd have to square root both hand sides. So when we square root, remember this is an equation, so you have to consider the positive and the negative solution. So this means y is equal to, and now we have to think about this. We're trying to find the inverse, okay? The original function had a domain of x is less than or equal to 0, and we can see that over here. As you can see, that tells us the x values of this graph. Now, what is the range that corresponds to this? Well, we can see this original right now. The range is where y is less than or equal to 0. Here's 0, and it only has y values that are less than or equal to 0. Now, what this would mean for the inverse is this. Here's the relationship between the inverse and the original graph. If the domain of the original graph was x is less than or equal to 0, and we saw that the range of the original graph was y is less than or equal to 0, what happens with the inverse is that in the same way that the x and y values switch places, the domain and range also switch places. So the range of the original function now becomes the domain of the inverse, while the domain of the original function becomes the range of the inverse. Now, right now they look very simple. So this will just be x is less than or equal to 0. It's just taking that, but it's still the domain. And this one will be y is less than or equal to 0. Okay, so it means that the range for this inverse is supposed to be y is less than or equal to 0. So we shouldn't take the positive solution, we should take the negative one. Okay, and you can tell them that by telling them that y is less than or equal to 0. So that is the range. And therefore, y is equal to negative square root of negative 9 over 2x. And this is our answer. Of course, when you write the equation of a graph, you can pair it with its domain as well. So we can tell them what the domain of this inverse is. And we can see that that is x is less than or equal to 0. And that is our answer. Question 4.3 says, write down the range of the inverse. It's only for 1 mark because we would have already figured it out in the previous question. So we can see that the range of the inverse is y is less than or equal to 0 using that previous question's explanation. And that is our answer. Of course, you could have also written this as y is an element of, and think about how it goes on a number line. You have 0, and it's the values that are either equal to 0 or less than 0. Okay, follow what the arrow is doing, it's pointing to the left. So how we would write this down is we always write it in interval notation. We start with the smallest number. The smaller number here would be that way, negative infinity. So we'll say negative infinity all the way to 0. And then we'll use a round bracket for infinity because it's not a fixed value, and square bracket for 0 because it is an included value in this equation. Y has to be less than or equal to 0. And that will be our answer. You can either leave it like this or like this, and it's perfectly fine. Question 4.4 says, sketch the graph of the inverse. Indicate the coordinates of any point on the graph different to 0 and 0. Okay, so what they're trying to point out there is this existing point that we have on the original. So I'm going to draw this graph with this because it's going to make more sense when you compare them together. Now, looking at our graph, the inverse is going to switch the x and y values of every point. So that also switches the domain and the range of the original and the inverse. So you see that we actually have 2 points on this graph, and that's why they told us to show another point other than 0 and 0. So we have 0 and 0, but we also have negative 6 and negative 8. So they're just going to switch x and y values. 0 and 0 will stay 0 and 0, but negative 6 and negative 8 would become negative 8 and negative 6. So if you went negative 6 and negative 8, okay, we went down further than you went to the side, then you'd go negative 8 and negative 6, and it will appear somewhere here. And then we can just put that down. So this would be the inverse. You can call it P prime. So it's going to be -8 and -6. And now for the shape of the graph. Notice that this is a concave down parabola, okay? And it moves towards the negative part of the y-axis, okay? It's down, moving downwards towards the negative part of the y-axis. It's going to do the exact same thing, but now it's going to do that using the x-axis. So that graph is going to look like this, okay? And that is what our inverse would look like. So now we can just get rid of this and just put down a Cartesian plane. And there we go. That is what our graph will look like. Moving on to the next question. Question 4.5 says the graph of f is reflected across the line y is equal to x. We already have this graph, okay? The graph of f was the original parabola, this one. And if it's reflected across the line y equals x, that is the inverse. Okay, that reflection will be the inverse of that. That line y equals x, okay, when it's reflected across this line, that's your inverse, which we just drew. So that is this graph. And they're saying that, and thereafter, it is reflected across the x-axis. And we need to determine the equation of the new function in the form of y is equal to. So what they're asking us to do is to take the inverse and reflect it across the x-axis. So if the inverse looks like this right now, if it's reflected across the x-axis, it's just going to look like that. So it's the same graph, but what changed? You see how this graph, the blue graph, its y values were all negative. See, it has y values that are negative all through. But now the reflection in the x-axis, because here's the x-axis, we reflect it in the x-axis, that graph has positive y values. So it means that all that will change would be the y values. Your range would change. In question 4.2, when we were finding the equation of this, right, you see how the range of the inverse was y is less than or equal to 0. Now we're just going to change our decision, and instead of making that range negative, we will make it positive. So how we would do that is when we were finding the inverse here, because it's still the inverse function, it's just with the other range, the positive y values. When we were finding that equation, at this point, we had to decide whether to take the positive y values or the negative y values. So we're taking this again, but this time we're going to take the positive y values since y now has positive values. Okay, only positive values. So we're taking this same thing again. And now when we're deciding on which y values to choose, we will say y is actually equal to the positive square root of -9/2x. That is going to be the equation of this new function. It's simply the inverse with positive y values. Okay, because the original was restricted, so this will also have a restriction. And we can see the restriction from this graph. Okay, you can see that the domain, all the possible x values of the graph, it would stay x is less than or equal to 0. This is where x is less than or equal to 0. And that is our answer. Question 5.1 says, the point P, which is 2 and the square root of 3, lies in the Cartesian plane. Determine the coordinates of the image of P if P is rotated about the origin through 90 degrees in an anti-clockwise direction. Okay, so we have a Cartesian plane first, and then we have this point P, and P is 2 and the square root of 3. So we know that 2 is greater than root 3, so it's going to go like 2 and the square root of 3. Basically, the length would be longer than the height. So let's just say somewhere over here, that is where we have 2 and the square root of 3. And this is going to be rotated about the origin through 90 degrees in an anti-clockwise direction. So clockwise, the hands of a clock move this way. So anti-clockwise is that way. Okay, so it's going to move that way 90 degrees, okay, about the origin. So here's the origin over here. And we could connect these. It really can just be construction lines, dotted lines that we'll have there. And let's just draw this line down to the x-axis so we can better understand this rotation. So this line is going to be rotated, and it's going to be rotated about that origin. So when we connect these together, you will notice that they will form 90 degrees because it's being rotated about the origin through 90 degrees. Okay, so here's a visual representation of how this rotation is going to look. Let's go ahead and look at this as a triangle. And it's going to be a triangle, but we'll focus on what this point does as it moves until it gets to this point. So here it is, and let's rotate that. Now, before rotating it, do you see that this side over here, that represents the y value of this point, okay? Because that is that square root of 3. We went up by the square root of 3 units. So that is the square root of 3. We'll just keep that in mind. And this over here represents the x value. So that is the 2. That's your x and your y value. And now we can just monitor what this is going to do as it rotates and then reaches this point over here. So from this, we can see that it still maintains that same triangle that was over here, where we had the square root of 3 units up and 2 units to the right. But now, because the point is over here, you can see that we're going from 0 and then we're going the square root of 3 units to the left. So as a coordinate, that would be the negative square root of 3, and the y value of that point would be 2 units up. Okay, so it was 2 units to the right here. It's going to be 2 units up here. And there we go. So that new point is negative root 3 and 2. So with rotations and in these types of transformations, these are topics that are taught in grade 8 and 9, but it's still something that you can logically think about. Okay, so you can leave whichever diagram you use to figure this out and tell them that the image of P is actually negative square root of 3 and 2. And that is our answer. Question 5.2 says, the graph of h of x is equal to a to the power of x is sketched below. And then a, negative 1.5, is a point on the graph of h, as we can see there. And 5.2.1 says, substantiate y, the coordinates of q, the y-intercept of h, are 0 and 1. Okay, so why is our y-intercept going to be 0 and 1? Well, we could just find it for them. We know that the y-intercept will be found where x is equal to 0, okay, because it's going to be on the y-axis where x is equal to 0. So we can simply take the equation of our exponential function, h of x is equal to a to the power of x, and in place of x we substitute 0. Okay, this would be y, because h of 0 is equal to a to the power of 0, and anything to the power of 0 is simply equal to 1, and that would be the reason why. So we know that q is 0 and 1. Therefore, q is 0 and 1. Moving on to the next question. Question 5.2.2 wants us to calculate the value of a. So to find the value of a, this is the equation that we have, and we have 1 point on this graph. So if we substitute that point, it will go in place of x and y, and that will help us to find a. So we can go ahead and say h of x is equal to a to the power of x, and we're substituting that point negative 1 and a half. So the y value is a half, so we say a half is equal to a raised to the power of negative 1. Okay, so looking at this, this is not an exponential equation because the variable is not in the exponent. But we can still solve for it like this. We can tell them that a half is equal to, now this is a to the power of negative 1. When a value is put to the power of a negative exponent, then what we can do is move it from where it currently is. It is actually in the numerator right now. It has a natural denominator of 1. So we're going to bring it down to the denominator, and when we do that, the exponent becomes positive. It's a positive 1, but you don't have to rewrite it. Now in the numerator, we have a placeholder of 1. That is not this one over here. They do not switch places. It's really just the one that was in front of the a. Okay, so this is what we have. And if 1 over 2 is equal to 1 over a, then this means that a is simply equal to 2. That is what A should be for this equation to be equal. Okay, and that is our value. Moving on to the next question. Question 5.2.3 says, write down the equation of the inverse function in the form of y is equal to. So we can update our equation. H of x now looks like this. Y equals, and we'll just write it in terms of y already. It is 2 raised to the power of x. So to find the inverse function, first step is we switch x and y. So in place of y, we say x, and in place of x, we say y. And then we need to make y the subject. To make an exponent the subject, we can use log. So y is equal to, and we'll say log, and our base is 2, because that's the number that was carrying the exponent, and the answer is x that we have over there. And that is our answer. Question 5.2.4 says, draw a sketch of the inverse of h and indicate the coordinates of 2 points that lie on this graph. Okay, so they're obviously referring to these 2 coordinates. This, okay, remember we had a y-intercept on the exponential, and then we also had this point over here. So the relationship between the original function and the inverse would work like this. Looking at the original function, it is an increasing exponential function. Notice how it shoots up towards the positive part of the y-axis. Well, it's going to do the same thing. The inverse is going to do the same thing, but it's going to do this on the positive part of the x-axis. Also notice another thing. Notice how it is closest to this x-axis on the negative part of the x-axis. This is where we have negative x values over here, right? And it moves from being very close to that x-axis and it gradually increases. Well, it's going to do whatever it's doing here. Since it's doing this on the negative part of the x-axis, the inverse is going to do this on the negative part of the y-axis. So we have a graph doing this. It's coming from being very close to that y-axis, and then it's going to shoot up. And that's what it's going to look like. So now we can actually just draw this graph down and point out those 2 important points. So it will look like this, and it will come from being very close to that y-axis, the negative part, and then gradually increase like that. Okay, and with this graph, now the 2 points that we need to point out. Remember how the original function, the exponential, had a y-intercept. If this has a y-intercept, the inverse graph will have an x-intercept because x and y just switch places throughout. All the points will just switch their x and y values. So this will have an x-intercept. So that one had a y-intercept at 0 and 1. This will have an x-intercept at 1 and 0. And then the other point that we have is that point on this graph. Since this was negative 1.5, this graph will have a point called a half and negative 1. Okay, so it's going to be a half and negative 1, and here's how we can find that. We can just say since this is 1, it's half, and then negative 1. So let's just say roughly about here. That is a half and negative 1. And there we go. That is the inverse of h. If you like, you can also show them that there is an asymptote, because here this graph is moving closer and closer to the x-axis. So this graph has a horizontal asymptote of y is equal to 0. Okay, it's horizontal. And then this one will have a vertical asymptote of x is equal to 0. And there we go, that is our graph. Question 5.2.5 says, read off from your graph the values of x for which log of x with base 2 is greater than negative 1. Now, we know this graph. We just found it, okay, in the previous question. This is this graph over here. See? There it is. So where is this graph? When they say that graph, they're referring to the y values of this graph. Where are the y values of this graph greater than negative 1? So looking at our graph, where it is equal to negative 1 is over here. That is this value over here. That's where it's equal to negative 1 at that point. It has a y value of negative 1. Now they want to know where it will have y values that are greater than negative 1. So this graph has y values greater than negative 1 all through here. See, all of these map to y values greater than -1. So if we highlight that, that is all of these parts of the graph. So now we just have to tell them the values of x for which these parts of the graph exist. So we know that it starts at 1/2, not exactly at 1/2, but when we line these parts of the graph to the x-axis to better understand the x values, that's a value over here on the right-hand side of a half. And then again, that's more to the right. And as you can see, look at these values over here. These are values that are on the right-hand side of a half. So these are values that are greater than a half. And that will be our answer, because you see that it just shoots up, and then all of those have y values that are greater than -1. So our answer for that question is simply that x is greater than a half. And that is our answer. Question 5.2.6 says, if g of x is equal to 100 multiplied by 3 to the power of x, determine the values of x for which h of x is equal to g of x. Okay, and this is for 3 marks. So we can just make the equations equal and then determine the values of x for which these two graphs are equal. So we're saying that h of x is equal to g of x. Now we know that h of x is 2 raised to the power of x. We already found that equation. So this is 2 raised to the power of x is equal to 100 multiplied by 3 raised to the power of x. And now to simplify this, you see that this has an exponent of x and that also has an exponent of x. So they can be expressed together as a fraction. So what we can do is just divide both hand sides by 3 to the power of x. And this now means that 2 raised to the power of x over 3 to the power of x is equal to 100. Now, because they both have an exponent of x, they have the exact same exponent, they can be written like this. 2 over 3 raised to the power of x is equal to 100. And all we're trying to do is to solve for x. You see that we can't just manually make 100 a base of 2 over 3, so we're going to have to use log here. So we'll say that x is equal to log, and our base is 2 over 3, and that answer was 100. And let's go ahead and find out what this gives us. And this is equal to, so x is finally just equal to -11 point, and that's going to round that 5 up to a 6, so 0.36. And that is the value of x. Question 5.3 says, the price P in rands per unit of each item in a consignment of Q items is given by this equation. And 5.3.1 wants us to calculate the value of P and the total price of the consignment when the consignment has 1,980 items. Okay, so when the consignment has that amount. So we have a price which is given by this formula over here, and you see it's in terms of Q. And this is the price per unit of each item in a consignment of Q items. So the consignment is some sort of, well, I guess we can just call it a package for now. And it has a specific amount of items in them, which has been denoted as Q. So we need to find the value of P and the total price of the consignment when the consignment has 1,980 items. So let's go ahead and find that value of P first. So we know that P equals log, and we have 10 plus Q over 2. So we are substituting in place of 1,980 items. That is the number of items that this consignment has. So they told us that that is Q. So that's what we're going to put in place of Q. So we'll say that P is equal to, and this is just the price, log, and this is 10 plus 1,980 over 2. And let's find out what P is first. On our calculator, we're going to say log, not this one with the base, okay? Log, and we have 10 plus 1,980 over 2. And you see that we have 3. So the price would be 3 rand. Okay, so that is the first thing they want us to find. They said find the value of P, which is the price. And now they want us to tell them the total price. So it means that this consignment of 1,980, right, it's going to cost 3 Rand per unit. But how many units do we have? We have 1,980 units. So to find the total price, we will say the total price is equal to the price per unit, which is 3 Rand, multiplied by the total number of items that we have, which is 1,980, which is equal to 5,940 Rand. That is the total price, and that is the price per unit. Okay, so we can just leave it as 3 since they just want that value of P. And there we go. So those are the 2 things they asked for. Moving on to the next question. Question 5.3.2 says, determine the number of items. Okay, number of items, that's Q. We need to find Q in the consignment when the price of each item is 2 Rand. The price of each item, that is the unit price. And that is P. So we see that from here. That's a unit price of 3 Rand. And that was the number of items, which is Q. So that's really what we need to do. We're going to take our formula for P, because this is the only thing that shows us the relationship between P and Q. We'll take this formula and we will substitute. So in place of P, this time we're substituting 2. So in place of P, we'll say 2. And we're going to find Q, and that will tell us the number of items that goes with this unit price of 2 Rand. So to solve for Q, because that's what we're trying to get to now, we can put this back in exponential form. So here's the thing about this log. The log that we usually use is the one that says log, and we have a base and then we have a value. With this, the base is always 10. So this one on your calculator over here, that's when your base is 10. So here is how we can rewrite this. We're going to simply say our base is 10, and then the exponent is always whatever the function, the log function, was equal to. So that is 2. So we're going to say 10 to the power of 2 is simply equal to this answer, the value in the parentheses, in the brackets. So that is 10 plus Q over 2. Okay, so 10 to the power of 2 is 10 times 10, which is 100. And we're saying 100, and we can transpose the 10. So minus 10 is equal to Q over 2. And that is 90. So we're saying that Q over 2 is equal to 90. And then to solve for Q, we can simply just multiply both hand sides by 2 to get rid of that denominator of 2. So therefore, this means that Q is simply equal to 180. So it means that this is 180 items that went for a unit price of 2 Rand. Okay, and that is our answer. And that is it for question 5. Question 6 says, sketched below are the graphs of f of x and g of x. So we have a straight line, a decreasing function, and a hyperbolic function. Okay, so the first question is to write down the domain of g. So the domain is all the possible x values that this graph has. So let's look at this graph, and first of all, let's look at the asymptotes, because the asymptotes are the only things that can restrict the graph. So we have 2 over x plus 1 plus 2. The original form of a hyperbola is y equals a over x minus p plus q. And p and q are your vertical and horizontal asymptotes. So in this case, because we have x plus 1, it means that your horizontal asymptote is going to be at x equals negative 1. Okay, because this is x minus p. For this to say x minus p, it will become x minus negative 1. And so we can see that is our value of p. Okay, so what this means is that this graph has a vertical asymptote at negative 1. So it's going to be a vertical line that will pass negative 1. Okay, so now looking at all the possible x values that this graph has. This graph is going to have x values all through. Okay, it has an x value over here, has an x value over here. See, the points on the graph map to real x values that we can see on our x-axis. Okay, and it's going to continue doing that over here until it gets to this point where x is equal to -1. Now, because we have an asymptote there, it will never touch this part. So it won't have that x value of -1. And then it will continue having every single x value after -1. So over there as well, and over there. And you see how these points all map to real x values. So this means that our domain is x can be any real number. So x is an element of all real numbers, but it will only not be equal to that x value of your vertical asymptote, which is -1. So that is our domain. Question 6.2 wants us to write down the equations of the asymptotes of G. We already have one asymptote. We have the vertical asymptote. So the second asymptote that we'll have is the horizontal asymptote. And that would be the value of Q. Okay, so that is 2 over there. So it means that your horizontal asymptote would look like this. It will pass 2 on the y-axis because it's a horizontal line. And so the equation of this line starts with y is equal to. So it's y is equal to 2. Okay, so we have both our asymptotes. Our asymptotes are the vertical one is x equals -1 and the horizontal is y equals 2. And that is our answer. Question 6.3 says, calculate the coordinates of D, a point of intersection of F and G. So let's look at where D is. D is over here. But do you see that there are 2 points of intersection? And the first one lies on the y-axis, okay? So we will know that that one, because it lies on the y-axis, its x value is 0. So in order to find that point of intersection, this is the point where the x value and the y value of both graphs are exactly the same. So we're going to equate the graphs. We're going to make those graphs equal to each other. So let's go ahead and just tell them that the graphs that we're working with, okay, it's G and F. So we'll tell them that G of x is simply equal to f of x. And this is G of x. That is 2 over x plus 1 plus 2 and then -x plus 4. Okay, so let's go ahead and simplify. We can just go ahead and leave this alone so that we can get to a point of cross multiplying. So we'll say 2 over x plus 1 is equal to, and we still have -x here, plus 4. And when we transpose the 2, it becomes negative. So that's 4 minus 2, which is positive 2. And now that we have a fraction and then this value over here, we can make this a fraction by just putting it over 1. And now we can cross multiply. So we are saying this x plus 1 times -x plus 2, which gives us x plus 1 multiplied by -x plus 2. And 2 times 1 is 2. So now we can distribute there. So that's going to be -x squared and then positive 2x and -x, and lastly positive 2 is equal to 2. Now you see that you have positive 2 on both hand sides. You can straight away cancel them out, because if you transpose this 2 over here, it will say 2 minus 2 and then they become 0. So let's just cancel them out on both hand sides. So now we can take these over, since the coefficient of x squared is negative. So that becomes positive x squared. And when these two subtract 2x minus x, we get positive x. When that gets transposed, it becomes a negative x is equal to 0. And to factorize this binomial, it has 2 terms, but we have a common factor in each. So we can take out the highest common factor of x that we can see there, and then all we'll be left with in the first term, x squared divided by x is just x, and negative x divided by x is -1 is equal to 0. And so this means that x is either equal to 0 or x is equal to 1. Now they specifically ask for the full point of D. We have to decide which one would belong to D. You see that there were 2 points of intersection, and that's why we have 2 x values. A was the one with an x value of 0 and D is the one with an x value of 1. Okay, so we're going to go for the 1. So let's cancel this one out and follow this. And now to find that point D, we can simply take this x value of 1, and because the x and y value of this point is exactly the same on both graphs, you can substitute it into any of the graphs. F is an easier graph to use, so we'll just go ahead and tell them that f of 1 is simply equal to negative 1 plus 4. That is simply 4 minus 1. So f of 1 is equal to 3. And that is our point D. D is simply 1 and 3. And that is our answer. And that is it for question 6. Question 7.1 says, at what annual percentage interest rate compounded quarterly should a lump sum be invested in order to double in 6 years? Okay, so we are investing an amount and we're going to have it double in 6 years. So this is compound interest growth. And the formula looks like this. It says A is equal to P multiplied by 1 plus I raised to the power of n. And the A value is the amounts that we get after the investment has grown. And we can see that they say that it should double. So we can just assign values to this. Since the end result must double, let's say that the invested amount is x. And so the accumulated amount would be 2x. So we're saying that 2x is equal to, and our principal amount is the investment, the initial one, so that is x. And then 1 plus the interest is what we're trying to find out. At what annual percentage interest rate, okay, compounded quarterly. But that's the thing, it's compounded quarterly. So we know that when we have our interest, we're going to divide it by whatever compounding it is. So in this case, we'll say I divided by quarters, that is going to be over 4, raised to the power of n. So that's going to be, the years is 6 years, but remember that this is compounded quarterly, so we need to have this in quarters. So that's going to be 6 multiplied by 4, so we can have quarters. Okay, and what we're trying to find out is the value of I. So we can straight away move on to getting rid of x. So we can divide both hand sides by x, and that's fine in this case because you know that x is not 0, okay? For the money to have doubled, it couldn't have been 0. So this 2x divided by x is 2 is equal to, and those cancel, and we have 1 plus I over 4, and 6 times 4 is 24. So now we can get rid of that 24 by finding the 24th root of both hand sides of this equation. And so we can just leave this as the 24th root of 2 is equal to, and that would break open because they are the inverse of each other. So that is 1 plus I over 4, and then transpose the 1. So that is again the 24th root of 2. Then that's minus 1 is equal to I over 4. And finally, we can get rid of this 4 by multiplying both hand sides of the equation by 4. So to find I, we're simply saying 4 multiplied by the 24th root of 2 minus 1. And let's find out what our answer is. So I in decimal form is 0.117208. And then we have to take that answer and multiply it by 100. And when we do that, our final answer for I is, and we're just going to have to show them here so that it is a rate. So it's going to be 11 point, and that's just going to round down to 72. So there we go, 11.72%, and that is our answer. Question 7.2 says, Michaela buys furniture to the value of 10,000 Rand. She borrows the money on the 1st of February 2023 from a financial institution that charges interest at a rate of 9.5% per annum compounded monthly. Okay, so that's the interest and that's the compounding. Michaela agrees to pay monthly installments of 450 Rand. The loan agreement allows Michaela to start paying equal monthly installments from the 1st of August 2023. Okay, so let's just look at this as a timeline. So first, Michaela gets a loan. She wants to buy furniture worth 10,000. So that is the full amount that she's going to borrow. Okay, so she takes out a loan on that amount on the 1st of February 2023. And then they're telling us that she's going to start paying for this on the 1st of August 2023. Okay, they also give us the interest and the amount that she's paying every month. The first question is to calculate the total amount owing to the financial institution on the 1st of July 2023. So that means that on the 1st of July, a month before she starts paying, because she's going to start paying here, this is where that present value amount, the amount that she owes, is going to be determined. So we're going to have to look at how many months she has missed. Okay, so this is the 1st of July. So this is following the normal procedure of present value and how loans are paid. You borrow money and you start paying the month after. So we're going to determine her present value, the loan amount, and then she starts paying a month after. Okay, so from 1st February to the 1st of July, how many months has been delayed? That will be exactly 5 months, because March, April, May, June, July. Okay, 5 months. So it means that this 10,000 that she borrowed, it's going to grow for 5 months. And so to allow it to grow, we're going to use, because this is compounded, we're going to use the compound growth formula. Okay, which again looks like this. And we're just going to say A is equal to, and we'll grow in 10,000 Rand. I'm going to say 1 plus, and the interest is 9.5% compounded monthly. So that is 0.095 over 12, and then raised to the power of 5 months. Okay, so we don't have to say times 12 in this case, because this is already in months. We're not converting. Okay, so let's see what that gives us. And the amount that it grows to is 10,402.15. And that is our answer. Question 7.2.2 asks us, how many months will it take Michaela to pay back the loan? So how long is it going to take her to pay back the loan? We have all the information we need right now. And if they're asking how many months, they really want us to just find the value of n. Now, this is the payment of loans, so we're going to use the present value formula, which looks like this. So the present value amount, this represents the amount that is owed at this point in time. Now, right now, Michaela owes this amount that we just found. She owes this over here. So that is what we're going to put in place of the present value. And don't worry, you can put down the rounded off amount, since this is an actual value that they asked us for. So in place of present value, we put in this 10,400, and then it's equal to an X. X is the monthly installments that she's paid. They told us that she is going to be paying 450 Rand as her monthly installment. So she's paying that every month, 450, and then 1 minus 1 plus. The interest is still the same, of course. It is 9.5%, so that is 0.095 over 12, and now raised to the power of. So remember that they're asking us how many months, so that's what we're trying to find out specifically. We'll say negative n. Now, I'm not going to multiply by 12, and here's the thing. We're trying to find out how many months, not how many years. Notice how whenever they give us the years, so for example, if they said it's going to take her 8 years to finish this loan, to complete this loan, then we would say 8 multiplied by 12, so that this is converted into months. Now, the reason we don't have to multiply by anything right now is because this would have given us the total months, okay? That would have given us the months. So instead of multiplying anything by 12, you might as well just leave it like that, because like this, it will give you the total months. The only time it will be necessary to multiply n by whatever compounding you have is when you're trying to find out how many years, for example, and it was compounded in months, because then you're going to still have to divide by 12 to find out how many years. Okay, and then this goes all over the interest, which is still 0.095 over 12. Okay, so all we're just trying to do here is to get to this point. Okay, let us simplify. So when simplifying this, I'm going to try to avoid decimals. So let's leave this as 10402.15, and then we're going to get rid of this denominator. So since this is a denominator, to get rid of it, you can multiply both hand sides by this number, right? And when we do that, what you do on this side, you have to do on this side as well. So we'll also multiply this side by it. And what's going to happen is over here, it would cancel. But over here, it will be multiplied by it. So this changes to this multiplied by 0.095 over 12. Okay, so at this point, the denominator is gone. So with this one, we're actually going to work with decimals at some point, but it's fine. And then we'll have 450 and everything in here. Okay, so it's going to look like that. Now, at this point, the next problem would be the 450. So to get rid of that, we can divide both hand sides by 450. And so it cancels here, but it's going to be on this side. So you can keep just writing that in that format, just so that we don't lose anything. We don't accidentally round off or, miss a number. Okay, so it looks like that for now. And then we have 1 minus and 1 plus 0.095 over 12 raised to the power of negative n. Okay, so at this point, do you see that we have the number that is the base because it's carrying the exponent, but do you notice that this is negative? So to make it positive, we can transpose it, so move it over to the left-hand side, and now it's going to be 1 plus 0.095 over 12, but it's positive now. But the n, of course, will still be negative because this is an exponent. And this will simply be equal to what's left on the right-hand side is the 1, and we can transpose everything that is here. So we're taking this over, and we're going to say minus all of this. Okay, so this is what we have, and at this point, we can start calculating. So you can put that on the calculator and find out what that gives you. And all of that gives us this, which we will not round off yet. So it's 0.816992, and that continues. And for this one, we can just leave it like this. That's fine. So it's 1 plus 0.095 over 12 raised to the power of negative n. Now we're at the point where we can actually find the exponent using log. So we'll make the exponent the subject, negative n is equal to, and this is log, and our base is this number over here. So that is 1 plus 0.095 over 12, and then the answer that we get is this. Now, in place of this number, we're going to say aunt, just so that we don't lose any decimal. Okay, so this is negative n is equal to, and let's go ahead and find this. Okay, so on your calculator, it's going to be recorded in aunts. So you might as well just go log and then put down that base, which is 1 plus 0.095 over 12. Then I'll close that bracket. And then in place of that, I'm going to put down aunts. Okay, so I'm going to use that aunts button. So aunt, and there we go. That's our full answer. So it is negative 25.6315. But of course, we are going to multiply both hand sides by negative 1 or divide by negative 1 as well. And that will give us our answer as a positive number. So it is just 25.63, right? Rounded off to 2 decimal places. Now, we would need to go back to the question just to see exactly what they were asking for, and so that we can understand what answer we should take. The question is, how many months will it take Michaela to pay back the loan? So here's the thing about this. But if we say that n is equal to 25 months, then she's not going to be done with this loan because she still has the 0.63 to go, okay? 0.63 months, and that is still money owed. So instead of saying 25, we'll say that she has 26 months left to go. And that is our answer. Question 7.2.3 says, what is the balance of the loan immediately after Michaela has made the 25th payment? Okay, so let's understand what they mean by that. You see, to find the balance of the loan, we can still use the present value formula. But you will notice that with the present value formula, we have a negative n. There's a reason it is negative. The n is going to tell you how many more payments still need to be made. You can see this in the previous question. You see how the question was, how long will it take her to finish paying off this loan? Okay, so how long will it take her? How many months will it take her to complete the loan? And we see that it takes 26 months. This tells you exactly how many months more you have to complete that loan. So if we're trying to find out what she will owe immediately after the 25th payment, right? So let's say this was the 25th payment. We saw that here when we found the value of n, when trying to find out how long it's going to take her to complete this loan, we see that we got 25.63. Now, it's that 0.63 that we're referring to there. At the 25th payment, she would still have 0.63 payments more to go. Technically, 0.63 months to go. So in order to find this, we can use the present value formula again, but in place of n, we're going to put 0.63 because this would be the payments left to go after she has reached the 25th payment. Immediately after the 25th payment has been paid, she has 0.63 payments left to go. Okay, so just remember that n tells you the amount of payments you have left to make. Okay, so let's put down the present value formula, and we are trying to find the present value. Okay, we're trying to find out how much will she owe immediately after the 25th payment. So this is left open, and then we know that x, she's paying 450 every month, right? That is 450, and so we'll say 450 and then open bracket 1 minus 1 plus 0.095 over 12 raised to the power of. Now, instead of rounding off here, we can actually keep those decimals, which we still have recorded on the calculator. So that is negative 0.63, and that just went on to 15. And we'll just do that just so that it shows that we didn't round off yet, because we're trying to find out exactly how much. Let's not cut out decimals in this case. And then we close that bracket, and then we put this all over the interest. So that's 0.095 over 12. And let's go ahead and put that in and find out what we get. Okay, now on your calculator, you'll still have this. So just to get that negative 0. Because we just wanted to stay negative, okay, it will be easier like that. So we don't have to apply a negative. You see, it's negative 25.63, and then that keeps going. So just add a 25 to it so that you can get the 0.63, okay? So that is equal to, and then we'll just say plus 25, and there we go. So that's what we want, and we're going to put that in place of that exponent. Just make sure not to say negative of that because it's already negative. Okay, so in place of the exponent, we'll just say aunt, and there we go. So there's our answer. The amount that she'll owe immediately after the 25th payment is exactly 282 Rand. And then we'll just round that up to a 6, so 0.36. And there we go. And that's how much she's going to owe exactly after the 25th payment. And that is it for the financial math section of this paper. Question 8.1 says, if f of x is equal to negative 2x squared plus 3x, determine f prime of x from first principles. Okay, so in order to find the derivative from first principles, we need to find the f of x plus h, okay, the second y value. So this is equal to, and we'll say in place of x, we'll substitute x plus h. So this is negative 2, and that is going to be x plus h all squared, and then plus 3, and in place of x again, x plus h. And let's distribute. So this is equal to, we still have negative 2. And here you can decide to say x plus h times x plus h, or you could just use this method. So we say the first term squared, which is x squared, the last term squared, which is positive h squared, and then first times second term is xh, and then we just multiply that by 2. So positive 2xh. Then here we can just distribute, and that is going to be positive 3x plus 3h. And finally here distribute. So negative 2x squared minus 4xh minus 2h squared plus 3x plus 3h. And that is our f of x plus h. Now the formula for the derivative from first principles is f prime of x is equal to the limit as h approaches 0. We have f of x plus h minus f of x, okay, y2 minus y1 over h. And that's the x plus h minus x, which simplifies to this. Okay, so now we can just go ahead and substitute. So this is equal to the limit as h approaches 0, and we'll take all of this and substitute it. And then minus f of x. And f of x is this. So in place of f of x, we'll say negative 2x squared plus 3x all over h. And then let's just distribute. So the limit as h approaches 0. So still we have all of this, and then these just distribute. So that's going to be positive 2x squared minus 3x. Now we already know that because we were subtracting by those, they're the only things that would cancel, whatever is like with them. So 2x squared cancels with negative 2x squared, and negative 3x cancels with positive 3x. So we just have the limit as h approaches 0, and we have negative 4xh minus 2h squared plus 3h all over h. And this is equal to the limit as h approaches 0. And now we solve the problem that we were having here the whole time. Okay, there's an h in the denominator, so we're going to take it out of the numerator so you can cancel with this one, and then we don't have an undefined value. So this is h out as a common factor and negative 4x. And then when h is out in the second term, we have negative 2h. And in the third term, we'll just have positive 3 all over h. And those h's cancel. And finally, we can just go ahead and substitute at this point. And then f prime of x is equal to, let's just write it one more time. So limit as h approaches 0. And we have negative 4x minus 2h plus 3. And now in place of h, we can substitute 0. So f prime of x is finally equal to negative 4x minus 2 times 0 plus 3, which is simply just equal to negative 4x plus 3. And that is our answer. Question 8.2 says, given f of x is equal to 3x squared over 2 minus 24 square root x, we need to calculate f prime of 9. So to find f prime of 9, we first have to find f prime of x, and then we can substitute a 9 in there. So how do we find f prime of x here? Well, this is not ready to be derived yet. Of course, yes, this is in the numerator, the x is in the numerator, but we have a surd with x in it, so we need to fix that. So f of x first is equal to, and we can just use this opportunity to rewrite this like this. We can say this is 3 over 2, and this is x squared, okay? And here, this is negative 24, and we're going to rewrite this so that its exponent is rational. So we're just going to have x, and the inside exponent, the exponent on the x is a 1, and the outside exponent, okay, is a 2. That's that square root. So we'll say inside over outside exponent, which is 1 over 2. And now we're ready to derive. So we'll say f prime of x is equal to coefficient times exponent. If you say 3 over 2 times 2, you see that the 2's cancel. So we're left with 3x, and then exponent minus 1 is 1, and we don't have to rewrite that. And then negative 24 times a half, that is negative 12. So we have negative 12x, and a half minus 1 is negative a half. Okay, so you see how we have this now? We can finally find f prime of 9. So we'll say f prime of 9 is equal to 3 times 9 minus 12 times 9 raised to the power of negative 1 over 2. And at this point, we can just substitute that into the calculator and get our answer. And our answer is 23. Okay, so that is specifically the gradient of this function where x is equal to 9. That gradient is 23. Moving on to the next question. Question 8.3 says a function g of x is equal to ax squared plus b over x has a minimum value at x equals 4. The function value at x is equal to 4 is 96, and we need to calculate the values of a and b. Okay, so g of x is equal to this has a minimum value. If it has a minimum value, it follows the same idea that when you have some sort of a curve, right, that minimum, the lowest it will reach, would be at the point where its gradient, this graph's gradient, is equal to 0. And to find the gradient of a function, you derive it. So what they're telling us here is that we have a minimum at x equals 4, meaning when you take the graph of g and you derive it, at the point where x is equal to 4, so g prime of 4, that gradient, okay, because g prime stands for the gradient, so g prime of 4 is the gradient where x is equal to 4, okay, of that graph of g. So that gradient is equal to 0. That's what they're telling us from this information, okay, the minimum value, a minimum value at x equals 4. And then they tell us that the function's value at x is equal to 4 is 96. Okay, a function's value is just its y value. Okay, if I say this is a function and I say the function's value at x is equal to 2 is 5, I'm just telling you the y value of that graph. Okay, so that means that g of 4, the graph's value, the y value, at the point where x is equal to 4, that is 96. These are the two pieces of information they have given us, okay, g prime of 4 and g of 4. And let's see how we can use this to find a and b. So it's more than enough. They've given us two pieces of information to find two missing variables. So here's how we can find this. G prime of 4. We can find the derivative of g, but check, is it ready to be derived? Not yet, because the x is still in the denominator, so we need to put it up to the numerator. So we'll rewrite g of x as g of x equals ax squared plus b, and then x raised to the power of negative 1. The exponent becomes negative when we move it to the numerator. And now we can go ahead and derive. So g prime of x is equal to coefficient times exponent, so that's a times 2, which is 2a, and then x, and then we'll say exponent minus 1, which is 1, and you don't have to rewrite that. And then b times negative 1, that's negative b, and x, exponent minus 1, which is negative 2. This is g prime of x. So now we need to say g prime of 4. So in place of x, we substitute 4 is equal to 2a times 4 minus b times 4 raised to the power of negative 2. And we're specifically saying that g prime of 4 is equal to 0. The gradient where x is equal to 4 is 0. So 2 times 4 is 8, and then we have a, and this is simply just negative b, and we can just move this to the denominator. If you move it to the denominator, then that becomes positive 2, and we know that 4 squared is 16. So this is what we have here. You can just go ahead and make b the subject, and then we'll substitute it into the other equation. So because this is negative, we can transpose it. So it's now positive b over 16 equals 8a. And then to solve for b, we can cross multiply. So b times the invisible denominator of 1 is b, and then is equal to 16 times 8. That is 128. And then we have a. Okay, so we can go ahead and call this equation 1. And now let's form our equation 2. So we're using g of 4 equals 96. In place of x, substitute 4. In place of y, we substitute 96. So that's g of x. We're going to say g of 4 is equal to a multiplied by 4 raised to the power of 2 plus b over 4. And then in place of g of 4, we say 96. That's the y value that goes with it. So this is 4 squared, which is 16a, and we have plus b over 4. And straight away, you can just call this equation number 2. You see that it's in terms of a and b. And now in order to solve for a variable, we're going to just substitute equation number 1 into equation number 2. So wherever we see b, we'll substitute it with 128a. So take this and substitute b. Okay, so here's our b, and we're just going to say that's 128a. Okay, and now we can finally solve for a. So this is 128 divided by 4. So we just have 96 is equal to 16a. Okay, 128 divided by 4, 120 divided by 4 is 30, so that's 32. So that's positive 32a. And then we're adding those together. So 96 is equal to 16 plus 32, that is 48a. And then we're dividing both hand sides by 48 to solve for a. So therefore, a is equal to 96 divided by 48 is 2, because it's double of it. And there we've solved for a. Now to find b, you see that equation 1 has b as the subject. So we'll say b is equal to 128a, and in place of a, we substitute 2. So b is equal to 256. And there we go. We have solved for a and b. And those are our answers. And that is it for question 8. Question 9.1 says, the graphs of g prime of x, which is ax squared plus bx plus c, they haven't given us anything there, and h of x is equal to 2x minus 4 are sketched below. The graph of g prime of x is the derivative graph of a cubic function, g. The graph of h and g prime have a common y-intercept at point E, then c, -2 and 0, and d, 6 and 0, are x-intercepts of g prime. Then they tell us that point A is the x-intercept of h, and point B is the turning point of g prime. Line AB is parallel to the y-axis. So that would confirm that since this is parallel to the y-axis, it's a vertical line. And so since these points lie on the same vertical line, they have the exact same x value. Okay, so that should tell us something. But the first question is to write down the coordinates of E. Okay, so E, as they said, is the y-intercept of the graph of g prime and h, but we already have the graph of h. It is a straight line and it is in the form of mx plus c. So that c part, that is our y-intercept. And we can see that that is -4. Okay, so that is -4. And so therefore, the coordinates of E are 0 and -4. Okay, because the x value is 0 at that y-intercept. And that is our answer. Moving on to the next question. Question 9.1.2 says, determine the equation of graph g prime in the form of y equals ax squared plus bx plus c. So this is our graph. So we're just going to have to look at what we have on this graph to be able to find its full equation. So as you can see, we have the x-intercepts. And then we also have one more point because we just found a point. We found the point E. So this is more than enough because they've given us x-intercepts. So we'll just keep in mind that that is -4. And here we can find the equation of this. So because they have given us the x-intercepts, we can simply just use the x-intercept method of finding a parabola's equation. So that is y equals a multiplied by x minus x1, and that's your first root, multiplied by x minus x2, and that's the second root. And the roots are -2 and 6, so we'll substitute that here. Y equals a, and then that's x minus -2, which becomes +2, and x minus 6. And this is what we have. And you can see that here, the only missing variable, because x is supposed to be x, the only missing variable is a. So to find one variable, we simply need one point on the graph. And we actually have that point. We have the point E, 0 and -4. So we're going to substitute that into this equation. 0 and -4 would be our x and our y value. So that is -4 equals a, and then in place of x we'll say 0 plus 2, and then 0 minus 6. Okay, so that's +2 and -6, which give us -12. So that's -4 equals a times -12, And then we can get rid of the negative 12 to solve for a by dividing both hand sides by negative 12. Therefore, a is equal to, that becomes positive 1 over 3. Okay, so now that we found a, we can substitute it back into the equation where a was missing. So in place of a, we just say 1 over 3. But remember that they want it in this form, okay, in standard form. So we have to distribute. So y equals 1 over 3. And if we FOIL out here, this is x squared, then we would say negative 6x plus 2x. And those give us negative 4x. And then lastly, 2 times negative 6 is negative 12. And therefore, y equals, let's distribute that third. So that's going to be 1 over 3x squared minus 4 over 3x and minus 4. And that is our answer. Question 9.1.3 says, write down the x coordinate of the turning point of G. Okay, so we found the standard form of this equation. We found the full equation, but we don't have to use that method to find it. Here's another way we can find this. Because they've given us the x-intercepts, we can find the x value of the turning point. The parabola is symmetrical about its turning point. So if we drew a vertical line, okay, that passed the x value of that turning point, you'll notice that what the parabola does over here, it does the exact same thing over here. And so to find that, this over here, this would serve as the midpoint of these two x-intercepts. So we can find that using the formula for midpoint, but specifically just the x-coordinates of that. So we'll say that to find x, okay, of that point B, it's equal to x1 plus x2 over 2. And that x1, those are our intercepts. So that's negative 2 plus 6 over 2. So negative 2 plus 6 over 2. And we know that 6 minus 2 is 4. So that is, the x value is simply just 4 over 2, which is 2. And there we go. That is our answer. Question 9.1.3 says, write down the x coordinates of the turning point of G. So not G prime, but G. So if this is G prime, like they told us, G is a cubic function, and they mentioned that in the info. They told us that the graph of G prime is the derivative graph of a cubic function. So if this is a concave up parabola and it was derived from a cubic function, it means that you had a cubic function that, let's just say, it has the shape of an n, okay? Because the a value in ax cubed plus bx squared, that a value was greater than 0, okay? So it's like this, but it's just more curved. And so what will happen is you have a graph that looks like that. And the turning points, we will find those turning points at these particular x values. Those turning points will be found where our x-intercepts are on the derivative. So the x value of this turning point, right, it's going to have the exact same x value as the x-intercept of the parabola, of its derivative. Okay, so that is x equals negative 2. And this local minimum's turning point, its x value is going to be at 6. So that's the relationship between a cubic function and its derivative. Okay, that's what we know about that. So they specifically just want the x coordinates of the turning points of G. So that is x equals negative 2 and x equals 6. And those are our answers. Question 9.1.4 says, write down the x coordinate of the point of inflection of the graph of G. Okay, so let's see where this point of inflection is going to be. So looking at the relationship between the graphs, the cubic function, when derived, it gives you a parabola. Okay, now that's really all we need to find the point of inflection. The point of inflection of the cubic function is going to be found at the same x value as the turning point x value. So we would need to find exactly what that x value of the turning point is. Okay, so to find the x value of the turning point, focus on the parabola. If this is a parabola, yes, we already have the equation of the parabola and we could just find it like that, but there's an easier way to go about this. We can simply say to find this x value, the parabola is symmetrical through its turning point. So it means that if you draw a vertical line that passed the x value of the turning point, that what this parabola does on this side is going to do the exact same thing on this side. Okay, so because of that, this line marks the midpoint of these two x values, okay, the x-intercepts. So if we find the midpoint of -2 and 6, that would give us the x value of this turning point, and that would be the x value of the point of inflection of the cubic function. Okay, so this is the relationship between a cubic function and its derivative. So to find that x value of the point of inflection, we just find the x value of the turning point of the parabola. So we'll use the midpoint formula, and we know that we're looking at -2 and 6. So we're just finding that x value, and we'll say it's equal to -2 plus 6 divided by 2, and that will find that middle, the midpoint. 6 minus 2 is 4, 4 divided by 2 is 2, so x is simply equal to 2, and that is our answer. Question 9.1.5 says, explain why g has a local maximum at x equals -2. Okay, has a local maximum. So clearly they're not asking you to find out whether it has a turning point at this point. We already know it has a turning point at x equals -2. Okay, we've established that from 9.1.3. But the question is really, why is that turning point a local maximum? Okay, so we can consider the shape of our cubic function. We knew that the parabola, the derivative of the cubic function, was a concave parabola, right? So it means that the cubic function looks like this, okay? Like an n, just moving forward. If a was negative, right, or if your parabola was concave down, then that graph would look like this, like a backwards n. So we know it looks like this. And we're not trying to just prove to them that this is a turning point, but specifically it's a local maximum. So we know that we have two turning points, right? And those turning points happen at x equals 6 and x equals -2. So why is the one at x equals -2 a local maximum? Okay, so for this question, here's how I will go about telling them that this is why this is the local maximum. So since they asked us to find the x value of the point of inflection, we can use that. We can just use that we know where this is now. So let's say this is our point of inflection at x equals 2. Here's the thing about it. We're going to first state that we know these are turning points by telling them that we know that g prime of -2, okay, is equal to 0. But then again, also g prime of 6 is also equal to 0. So what this is actually saying, though they're just like numbers that we're using, what we're actually communicating to them is that the gradient of this graph at x equals -2 and the gradient of this graph at x equals 6 are equal, and they're both equal to 0. So that is concluding that the turning points are at x equals -2 and x equals 6. Okay, so these are simply just some stationary points that we have here. Now, since we have stationary points here, and now we're going to use that point of inflection. If the point of inflection is here, okay, which is perfectly normal, it's in between the stationary points, okay, it's somewhere in between it. If we know that from the shape of this graph, the graph is concave down, and here's how we tell them that it's concave down. We tell them that the second derivative of this graph would be less than 0. It's going to be concave down for x values that are less than 2. And we can see that here. See, x values less than 2, all of these values here are values less than 2, and that's where the graph is concave down. So we know that there is a turning point over here, but this particular turning point exists where the graph of g is curved down, it's concave down. So it means that this is your local maximum. It can't be a local minimum because the graph would not be concave down. It wouldn't be curved down. It's curved down and there's a turning point here. So that makes that the local maximum. Okay, so we can finally conclude. So we're just telling them we have two stationary points at here and here, but the graph is curved down where x is less than 2. Therefore, that has to be the local maximum. So G has a local maximum at x equals -2. And that is an explanation of that. That is a possible answer that we could use. Okay, moving on to the next question. Question 9.2 says, given h of x is equal to 4x cubed plus 5x. Substantiate whether it is possible to draw a tangent to the graph of h that has a negative gradient. Okay, we need to tell them whether it is possible to draw a tangent to this graph. So it's a cubic function. Maybe it looks like this. Okay, so it's that positive one. So we have this, and they need us to find out whether we can actually draw a tangent with a negative gradient to this graph. So tangent to the negative gradient simply just means that tangent, since it has a negative gradient, it means that at that particular point of contact with the graph of h, that gradient, the gradient of that point is negative. In other words, what we're saying is that the gradient of the graph of h will be negative. The question is, can this ever happen? Can we ever have a situation where the gradient of h is negative? In a nutshell, that's what they're asking us. Okay, so looking at this, can we ever have this situation? So we're going to need the graph of h, and we're trying to find out whether the gradient can ever be negative. So we need to derive that. H prime of x is going to be, let's just find h prime of x. It is 12x raised to the power of 3 minus 1 is 2. And then that's just going to become a plus 5. So this is h prime of x. The question is to find out whether this can ever be negative. Can it be less than 0? Okay, so we're going to have to examine this expression and the nature of this expression, the kind of y values it can get depending on the x values you substitute in. Now, we don't have to do that one by one by substituting actual x values. We can just look at it based on certain features that it has. First, it has x squared. Let's talk about x squared. X squared is a value that can either be greater than or equal to 0. That's the only thing it can be. If x is equal to 0, it's going to be equal to 0. If x is a negative or positive value, it will always be greater than 0 because we are squaring this expression. Okay, so we can see that this part is always going to be positive. And now let's look at this part. So we're looking at it term by term. Okay, let's look at this term as a whole. When we say 12x squared, this is also going to either be greater than or equal to 0. Because if this ends up being equal to 0, if you multiply by 12, it's still going to be 0, okay? And it could also be any value that is greater than 0. Because regardless of whether this is negative or not, let's say it was -2, you see, that gives you a 4. But then you're going to say 12 times 4, which is still a value greater than 0. Okay, and I'm not even being specific here. We're saying x squared is greater than or equal to 0 for all x values, all real x values. And likewise for this part as well, also for all real x values that this would work out for. Okay, so now we know that this part will always be either greater than or equal to 0. Now this expression then goes and adds a 5 to this. So that means that 12x squared plus 5, because this part will always be greater than or equal to 0, this plus 5 will always just be greater than 0. Not necessarily equal to 0 because this part can be equal to 0, okay? But then when you add 5, it's of course going to be greater than 0. Okay, so this is greater than 0 for all x values, all real x values, I mean. Real values of x. We can see how that works out. So, can this expression ever be negative? No, that's impossible. Okay, so I can also just tell them that 12x squared plus 5 can never be less than 0. And so we can finally conclude and tell them that it is not possible. So it is impossible for a tangent to be drawn to a graph of h that has a negative gradient. And that is just our conclusion. Okay, and of course, this is also for all real values of x. So in conclusion, it is impossible to draw a tangent to h that has a negative gradient. And that is our answer. Question 10 says, the diagram below shows the plan for a veranda which is to be built onto the corner of a cottage. A railing ABCDE is to be constructed around the four edges of the veranda. Okay, so the railing is going to go here, like that. And then they tell us that it is given that AB is equal to DE. And so we should just note these down. AB equals DE, which is equal to x. So you see that x over there is also here. That's x as well. And then BC equals CD, which is equal to y. BC is y as well, and so is CD. And they tell us that the length of the railing must be 30 meters. So we also know the length of that entire railing. If you add all these up together, they give you 30 meters. And the question is to calculate the value of x and y for which the veranda will have a maximum area. Okay, so we can see that this is an optimization question. So we're going to solve for x and y, find out what they should be so that the veranda will have a maximum area. Where's the veranda? It's over here. So we need to find the area of this shape. But in order to find the maximum area, we need to first find the area of the shape in terms of either x or y. Okay, now what is the information that they have given us to find this? They first told us that the railing is 30 meters long. So we have a reference for what x and y added together would give us. Okay, those values. So we can put that down first. We can tell them that x plus y, okay, moving like that, and then plus y plus x, that all of that is equal to 30 meters. And so if we simplify this, this is 2x plus 2y is equal to 30. And I'm just going to go ahead and make 2y the subject just so that it's going to be in terms of x. Also, it's really just because, we've got a length here and a length here of y. So we might as well just find a value for y, an expression for y. So 2y is equal to 30 minus 2x. And if you divide both hand sides by 2, therefore y is equal to, that will be 15 minus x. Okay, so we have a value for y. And now we're really just trying to find the area of this shape. Okay, so I'm seeing two ways that we could do this. We could look at the area like this, as this rectangle like that. And then we could say that entire area minus this rectangle's area. And then that will give us the entire veranda's area. And to do that, we would need the value of FE and FA. And another way to do this is we could just divide this like this. So it's kind of just extending FA. And so you see this entire length, that would be y. And we can see that that is also y. And then we would just need to find an expression for this. And yeah, we can already see that that expression is x. Okay, so it's a rectangle and AB is already equal to x. So that will be equal to x. I will go with this method instead. And then we'll find the area of this part over here. And that would really just solve it. We would add those two areas together and that would make up the entire area of the veranda. Okay, so let's just put it down and just see the things that we'll probably need to find. So this is x, that is y, and then this entire length now is y. So we're treating that as a rectangle on its own. And then this part over here. Now, we already have that this is x, so we know this is also x. Now, what is this over here? You see that this part, if you had to just take that FE and extend it to this bottom over here, right? It completes this big rectangle. So it means that to find FE, we could do this. We could just say this entire length of y, because that's what this is, it's y. We could take the entire length of y and say minus x. And that would be this little part over here. That's y minus x. Okay, so that's one part that we need to put down. So we now know that FE is y minus x. And then this is enough. We have a length and we have a width. So that can find the area. Okay, so let's just put down the things that we would need after this. So we can tell them that CD is equal to y. And they already told us that. And another thing that we just need to tell them is how FE is actually equal to y minus x. So FE equals y minus x. And this is all we need. We already have an expression for y, and we have all of these in terms of x as well. So let's go ahead and start finding the area. So we'll find the area of this bigger part first. So the area of the entire veranda is made up of this. We'll say area equals, so this bigger part is length times breadth. So we're going to say y multiplied by x. Okay, so that's what we have there. So we'll leave it as y at first, y multiplied by x. And if you take that and you add it to this part, and this is again length times breadth. So you can take anyone as the length. We'll say x multiplied by y minus x. Okay, so that is multiplied by x times y minus x. And now in place of y, we can substitute 15 minus x. So this is going to be the area in terms of x. Therefore, this is a of x is equal to, and this is y times x. Now, y has two terms. Since it's multiplying by something with one term, we can just say x multiplied by, this is y, 15 minus x, like that. And we're adding this to x multiplied by, this is y, and that's 15 minus x. So that is 15 minus x, and then still we have that minus x. Okay, so a of x is equal to, and that's going to be 15x and negative x squared. And then we distribute that, that is 15x. And when we distribute, that's just going to be negative 2x. So when we multiply that in, that's going to be negative 2x squared. So minus 2x squared is what we have there. And we can just finally simplify this. So a of x is equal to, like terms together, and those are x squared. So that's negative 3x squared. And then we have these two will add. So there's simply just 30x. Okay, so now we're at this point where we can finally solve for x and y. We're specifically asked to find the value of x and y for which the veranda will have a maximum area. So we're trying to find out the value of x and y for which this will be a maximum. And right now, this is already a parabola. It's a concave down parabola. To find that maximum, we're trying to find out where the gradient is equal to 0. So the gradient of this function will be equal to 0. And that's really what we're trying to do. So we'll say a prime of x is equal to 0, but let's just derive that first. So this is equal to negative 6x and plus 30, and the x falls away. And we're just saying that 0 is equal to negative 6x plus 30, transpose the negative 6, so 6x equals 30. And if we divide both hand sides by 6, x is therefore equal to 5. And we just need to remember the units of measurements we were using. We were using meters, okay? So 30 meters was the length of the railing. So x needs to be equal to 5 meters. And what should y be? Well, we already had an equation for y. So here we can just substitute x there in place. And so y is finally equal to 15 minus 5. Therefore, y equals 10 meters. And that is our answer. X should be equal to 5 meters, while y is equal to 10 meters, so that we can have a maximum area. Okay, and that is it for question 10. Question 11 says, let A and B be two events in a sample space. Suppose that probability of A is 0.4, the probability of A or B is 0.7, and the probability of B is K. For what values of K are A and B mutually exclusive? Okay, so with mutually exclusive events, remember, they have mutually agreed to exclude each other. These events do not intersect. So because they do not intersect, you will know that the probability of A and B, that intersection, should be equal to 0. Okay, so that's what we need to search for, the probability of A and B. And then we'll set it equal to 0. So let's look at what they've given us. They've given us the probability of A or B. Okay, so A or B already. And they gave us the probability of B. So it means that we can use the probability of A or B's rule because it includes the probability of A and B. So that rule looks like this. The probability of A or B is found by saying the probability of A plus the probability of B minus the intersection of A and B. And with this, we can make this the subject since this is what we are looking for. So we can transpose this, take this over. So it's now the positive, okay, because this was negative. So we're just going to say positive probability of A and B is equal to, and we still have these on the right, so the probability of A plus probability of B, and we can go ahead and transpose that. So minus the probability of A or B. And then this is equal to the probability of A and B equals, and let's just put the values down. So that is 0.4 plus the probability of B, which is K, and then minus the probability of A or B, which is 0.7. So this means that the probability of A and B is simply equal to K, and then we can say 0.4 minus 0.7, which is negative 0.3. And all we're just trying to tell them is for these to be mutually exclusive, remember that means they shouldn't have an intersection, then it means that the probability of A and B should be equal to 0. Therefore, K minus 0.3, since it represents A and B, should be equal to 0. And this is a linear equation, so K simply should just be equal to 0.3. And that is our answer. Question 11.2 says, for what value of K are A and B independent? Okay, so we know that for independent events, the probability of A and B should be equal to the probability of A multiplied by the probability of B. Okay, so looking at the previous question, here we had to find out for what value of K would they be mutually exclusive. And here we're trying to find out for what value of K will they be independent. Notice that they cannot be both at the same time, because if they are mutually exclusive, then it means that the probability of A and B is equal to 0. And you see that if they are independent, the probability of A and B should be equal to A multiplied by B, not 0. So them being independent means they do occur at the same time, hence they cannot be mutually exclusive. Okay, so let's find out what that probability of A multiplied by the probability of B is. The probability of A, that's 0.4, and B is K. So we're saying 0.4 multiplied by K, and this is equal to 0.4K. Now for this to be independent, we need to ensure this case. So we're going to really just write this here and then substitute. Okay, so what was that intersection, the probability of A and B? We already found that by using the OR rule, the probability of A or B, and then we found that the probability of A and B is K minus 0.3. So we can put that here. It's K minus 0.3, which is equal to, and we know that this product gives us 0.4K, and we just need to solve for K in this equation, and this will tell us the value of K for which they are independent. Okay, so for both cases, we're using the probability of A and B, which we get from the info above. So this is K, and then if we transpose that, it's minus 0.4K. Transpose that, it's positive 0.3. So K minus 0.4K is like saying 1 minus 0.4, which is 0.6K is equal to 0.3. And then to solve for K, we can divide both hand sides by 0.6. Therefore, K is simply equal to, that's like 3 over 6, which is a half. And that is our answer. K should be equal to a half for these events to be independent. And that is it for question 11. Question 12, 12.1 says, the data obtained from a city's police department indicates that of all motor vehicles reported stolen, 80% was stolen by syndicates to be sold off, and 20% was stolen by individuals for personal use. Of the vehicles presumed stolen by syndicates, 24% were recovered within 48 hours, 16% were recovered after 48 hours, and 60% were never recovered. Of those vehicles presumed stolen by individuals, 38% were recovered within 48 hours, 58% were recovered after 48 hours, and 4% were never recovered. And we need to draw a tree diagram for the given information above. Okay, so with this information, you can see that they've already split it into two categories at first. So, of all the vehicles stolen, 80% was stolen by syndicates to be sold off and 20% by individuals. So, this is the one stolen by a group, and then this is by individuals. That has already been split into two categories. So this is how we're going to do this with the tree diagram. We're going to have two big branches, which is going to be, the first one would be the vehicles stolen by syndicates, and we're just going to say, I'll just say S, and then individuals. Okay, so that was 80% for syndicates and 20% for individuals. So that is 80%. So we'll put that over here, 80% and then 20%. And then these have categories of their own. Okay, so vehicles presumed stolen by syndicates. 24% were recovered within 48 hours. So for that, we can see that we have three branches. Recovered within 48 hours, recovered after 48 hours, never recovered. So that's three branches in here. So if it was stolen by a syndicate, the probability that it was recovered within 48 hours would be, and they told us that that is 24%. So we'll put that there. Okay, 24%. And then that it was recovered after 48 hours. And then that is 16%. So we're just going to put these down. And then that it was never recovered would be 60%. So over here, I can just say never recovered, NR, okay? And that is 60%. And then from the cars stolen by individuals, then the ones that were recovered within 48 hours, that was 38%. So that's 38%. And then after 48 hours, recovered after, that was exactly like they say here, that is 58%, and then we have 4% were never recovered. Okay, so 58% here, and then 4% here, never recovered. And yeah, that's what our tree diagram looks like. They don't really ask for any outcomes. If they wanted outcomes, they would have said draw tree diagrams, with the outcomes. But they didn't ask for that, so we can leave it like that. It has the two branches for syndicates and individuals, and then also the three branches in each. Okay, so that is it for the first question in question 12. Moving on to the next question. Question 12.1.2 says, calculate the probability that if a vehicle was stolen in this city, it would be stolen by a syndicate and recovered within 48 hours. So, stolen by syndicate and recovered within 48 hours. That's what we need to look for. Okay, so the first branch, we're going for syndicate. That's 80%, and then it must be recovered within 48 hours. And that's 24%. So we're going to multiply those. That would be the probability that those two events happen at the same time. So tell them that the probability that it was stolen by a syndicate and then at the same time it was recovered within 48 hours. And that is equal to, so that was 80%, so that's 80 over 100 multiplied by recovered within 48 hours was 24%. So we'll say 24 over 100, and let's just find out what that gives us. And that is 24 over 125. Okay, and I'll just leave it as a fraction. And that is our answer. Question 12.1.3 says, calculate the probability that a vehicle stolen in the city will not be recovered. Okay, so this is regardless of whether it was stolen by an individual or a syndicate, it's just not going to be recovered. So here's how we can find this. We're going to look for all the branches that pair with not recovered. So here's not recovered. So this is if it was stolen by a syndicate and not recovered, we will take that pair, okay, 80% times 60%. And that means, or we can also consider the case where it was stolen by an individual and it was not recovered. These two are applicable. We can use those two cases. So here's how we can show them that. We're saying that we are just going to focus on not recovered, okay, regardless of whether it was stolen by an individual or syndicate. So we'll say the probability that it was stolen by a syndicate and it was not recovered. Or, and when we say or, we're adding, we're increasing the chance. So we're saying plus the probability that it was stolen by an individual and was not recovered as well. So let's find that. Probability, syndicate, and not recovered is 80 times 60. So here we're going to say 80 over 100, 80%, times 60 over 100. And then plus individual and not recovered is 20% times 4%. And so that is 20 over 100 times 4 over 100. Okay, and let's go ahead and find this. Okay, and the answer to that is 61 over 125. And that is our answer. Moving on to the next question. Question 12.2 says, you have to choose a password for your new Facebook profile. The password must be in the format of, okay, they're saying that this is a digit. Okay, so digit, digit, digit. And they also say that zeros are not allowed. And the @ symbol is any vowel, A, E, I, O, U. You may repeat any digit, but you may not repeat a vowel. How many passwords can be formed? Okay, so those are the way this is structured. It's simply just in the format of a digit first, a digit, and a digit. Okay, so we're going to have that there. And then two vowels. So vowel and a vowel. But you can't repeat the vowels. You can repeat the digits. And you're not allowed to use zero. Okay, so it means if you can't use zero, you were going to have 10 choices. 1, 2, 3, all the way to 9, including 0. But now you can't use 0, so you only have 9 choices of numbers from 1 to 9. So you can repeat the numbers, meaning here you have 9 choices of numbers that you can use. In the second digit, you have 9 choices, and the third digit, 9 choices. Okay, in the first vowels character, you see that we are only allowed to use these letters. So in the first vowel, you can use 5 choices. But after 1 has been placed down, you only have 4 options left, okay? Because you're not allowed to repeat in this case. So that is what it's going to be. 9 times 9 times 9 times 5 times 4. And let's see what that gives us. Okay, so the total passwords we can form with these instructions is 14,580 passwords. And that is our answer. And that is the last question for question 12. Okay, so that is it for this paper. I hope you guys enjoyed it, and I will see you guys in the future videos.